Assalamualaikum, this is Attaullah, Network and vSphere Administrator and Virtual Instructor of Cisco and VMware Technologies at Nanotech X. This is the third last session of free Nanotech X Networking Bootcamp. Today is session 13, live now. So let's start. Today we have to perform 3 labs. So let's start the labs. This is your box. So our first lab would be in GNS3. Today our target is to perform 3 labs maximum, if possible. So how to create project? You all know about this. Let me show you. First of all, you should click on this icon. After this, you should write the project name. For example, today project name is 7 routers in a network. So project is created successfully. And let's take some routers here. Okay. So this is router 1, router 2, router 3, router 4, router 5, router 6, and router 7. Okay. So let me connect them first. Before connecting, let me assign the slots to them as well. Like I will assign PF4 here. Means in one slot for each ports, you mean Ethernet ports. I will try to design this topology for you as well, so it should be interactive. Okay, now let me design these as well. Let me give it some style. Now it's open. So 7 routers mean we will connect today 7 different vendors, 7 different companies. And I should give them some different colors because it will represent different companies. So it means 7 routers mean I will connect today. Each company would have 1 router, so I will connect 7 different companies. So you know this would be a big project. Why? Because if you connect different 7 companies which belongs to different network and want to communicate devices of 7 different companies on different locations, so it's a big task I think. So this project would be a big project for all of you. So let's try to connect them, but let me give them some different fill colors because it represent different vendors, so that's why. So yes, finally we done with the class with the styles representing different companies. Now let me write the names of the companies as well. For example, the company name is company A, and the company name is company B, and this is company C, and this is company D. So obviously we have many companies, 7 companies. So this is company D, and this is company E. Okay. This is which enterprise, which company? F. This is company G. Okay. Let me allow the member here. This is chat box. If you have any queries, you can ask in this chat box. Okay. So welcome our members. So now we should connect them because in networking, when you create a network, so obviously you should connect them first, then you should make them able to communicate. So first let me make them connect with each other. So how to connect these different companies routers? Now look at this. This is connected with this company, and now we will connect this one. And remember, in today's session, after this project, we would have a lab in which I will give you answer. In previous session, I have told you that I will give you answer of the switches, then how the 8 physical switches can be converted to 45 V switches. So today I will give you answer practically after this day. So wait for that. Okay, these are now connected. Let me start them. But before that, let me give some IP addresses to these ports as well. So let me give them fastly, like 1.1.1.1. Here 1.1.1.2. Here 2.1.1.1. Here 2.1.1.2. And here 3.1.1.1. So let me allow the member who's requesting to join. Let's continue now. Okay, so this is 2.1.1.1.2. Let me place it here like so you can see it clearly. Let me give this 3.1.1.1.1, and I'm giving today our class A IP addresses. Okay, so obviously subnet mask will be 255.0.0, means the first octet in class A is for network and the last two octets in class full addressing is about what host. So this will be 4. This would also be 4 network, because in class A the first octet represents the network, so network will be same, just the last 3 octet represent host, so it should be different because we are assigning these IP addresses in the same network but in different ports, so that's why. So this is same network but the ports are different, so that's why the host part last 3 octet represent in class A host, so that's why this should be different, like 1.1.1 is different from 1.1.1.2, but the 4 is same because in class A the first octet represents the network bit, network octet, so that's why this is same in this network, which is same network here. So let's assign to this port as well. How it would be like 5, and it would also be like 5 network, but the host would be that 2 different from another host. So these are connected. Let me make them start. How? The same procedure, click on this button, which means start or resume all nodes. So it will be started as you can see here. These are red means off, green means on. Look at this. These are red means it is off now, and green mean it is on. So look at this now. This should be now on. Yes, green on. So these are connected. Our first part in networking lab is completed to make a network. So we would have 2 steps: connectivity plus communication. So connectivity is completed. Now we have to configure them to make them able to communicate with each other. So in this project we will communicate different 7 companies network. It would be a large task. So let's try. Click on this button, which means we are taking console. So they are started. Now let's start configuration. Okay. Okay, now it's okay. First, I want to go from privileged execution mode to global configuration mode in each router. Why we are going to global configuration mode from privileged execution mode in each router of each company? Why? Whatever the reason. Because in that mode we can configure the router. So that's, and if we don't configure, then they will not be able to communicate, even if they are connected like in this form. So that's why. After connectivity to make a network, we should make them able to communicate with each other as well. So let me change the host name here to R7 and let's look at this as well, and let me go from privileged execution mode to global configuration mode to configure these routers and make them able to communicate with each other. So how to configure? Same way in which I configured the previous routers in the previous session. So how? Right here, interface, what is the name, ethernet, what is the port number, 1 by 0, and right here IP address, what, this one, subnet mask is this one, and say no shutdown. So the same procedure to all ports, and as you can see, change state to up. Right interface, ethernet, 1 by 1, IP address 7.1.1.2 255.0.0.0, no shutdown, exit. And same procedure to all company routers to give them IP addresses so that they can communicate through logical address. Because if it haven't logical address, then how they can communicate with each other? How they will know that to which router port I want to send the data? So that's why. So I've assigned IP addresses and make the ports up for communication in router 1. Now let's come to router 2 and same procedure. If you know the first procedure, then you can do the same thing here as well. How? Right here, interface, ethernet, 1 by 0, and IP address is which one? Same procedure with another port of this router as well. Now look at this, change state to up. This port is up for communication now. Right here, interface, ethernet, 1 by 1, IP address is 2.1.1.1 255.0.0.0. It is subnet mask of class A. IP address 2.1.1.1. Say this port no shutdown. Keep yourself up for communication. And now as you can see, this port is up for communication. Let's configure this company C router as well. How? Same procedure, nothing different. Right here, interface, ethernet, 1 by 0, the port number of ethernet, and right here IP address, which is 2.1.1.2 255.0.0.0 is the subnet mask of 2.1.1 IP, and send off down to this port, so it would be up for communication. And as you can see, the result, this port is up for communication. Right here, to configure another routed port means to which we can assign IP address and which is by default down, so that's why we say no shutdown. So it will be up for communication. So how to configure this port the same way, right? Interface, write the name of the port. So what is the name? E means Ethernet. So right here, Ethernet. And what is the port number? As you can see, company C, this port number is configured, but this port number remaining. So right here one by one. After this, right here IP address 3.1.1, and right here the subnet mask of class A, this one, and here's the spelling mistake. And as you can check the result, this port is up for communication. Now let's configure this out as well in the same manner. Right here interface, and if you write small e or capital E doesn't matter. It's not case sensitive. Okay, let me allow the member. And on this time we should configure company D router port Ethernet 1 by 0. Okay. So if you have any question, you can ask in chat box. I will attend the questions if you ask. So during the lab, you can also ask the questions if you have any confusion in lab, etc. So it's interface Ethernet 1 by 0, right IP address. And what is the IP address? As you can see here, 3.1.1.2 to this port 1 by 0. So 1 by 0, and IP address is this one. This is subnet mask of class A. How to find subnet mask of any class for addressing I shown you in yesterday session. You should watch that. Right here interface Ethernet, and as you can see the result, the port is up, but this is out port by default down for communication. And now when we say no shutdown, so it's up for communication. Change state from down to up, and interface Ethernet 1 by 1 is remaining. So also we should configure this out port means to which we can assign IP address. So what is the IP address of this 1 by 1 port? 4.1.1.1. As you can check, the result change state to up. Now let's configure this out as well. Right here, interface Ethernet 1 by 0, IP address for that 2, subnet mask 255.255.0, sorry 255.0.0.0, and channel shutdown. Exit from this interface and come to global configuration mode, and after that go to global configuration interface mode. So how? Right here interface Ethernet 1 by 1, I mean this port to configure this IP, and this change set up of this port. So right here IP address 5.1.1.1 255.0.0, and write no shutdown. And as you can check the result, change set to up. Now let's configure the company F router. Okay. Right here interface Internet 1 by 0, IP address 5.1.1.2 55.0.0. No shutdown. Sorry, what is spelling? This is like no shutdown. Okay. Exit from this interface and go to another interface by writing interface Ethernet. This one port. Okay. This 1 by 1, and this port is now up for communication. Right here to configure this routed port to which you can assign IP address. Right here IP address, note IP is of class A 6.1.1.1, and subnet mask of class A is this one 255.0.0.0, and right here no shutdown. to make this port up for communication. As you can see, the result change straight to up from down. Because it's routed port by default, let is down for communication. Now let's configure the last router, means company G. Same procedure. And as you can see, the result change straight to up. Interface Ethernet one by one. IP address 7.1.1.2 is submit mask of 7.1.1.2 IP address of class A, and these are configured. Now let's check the interfaces. Reports of all companies router by writing this command to show IP interface brief. Yes, up for communication in IPs assigned. Let's check this one. Yes, these ports are up for communication in IPs assigned. Okay, let's check this router. Yes, up for communication in IPs assigned. Let's check this one. Yes, it's also correct. Let's check company E router. Yes, but the spelling is not correct. Yes, it's also okay. Let's check the company F router as well. This is also okay. And let's check the last router. Yes, all are okay. But the main thing is that let's check the routing table as well by writing the command do show IP route, and only two routes would be available in each routing table, which are connected routes like 1 and 7. Look at this, 1 and 7 network is available. In this router, same situation. Let me show you. Only connected networks are available, like which one? 1, 2. So yes, 1 is connected and 2. So it is available. In this same situation, look at this. Only connected routes are available. 2 and 3. Yeah, 2 and 3 are connected. And if we look at this, so yes, only connected routes are available 3 and 4. So yes, 3 and 4. Let's check this one. Only connected networks are available 4 and 5. Yes, 4 and 5. Let's check this one. only connected 5 and 6 networks are available, 5 and 6. And let's check company G router network routing table. So do show IP route. Yes, only connected two networks are available, 6 and 7, 6 and 7. So the problem is that if in each routed only connected routes are available, then it doesn't mean that, it means that they can communicate with their connected routes, connected ports, not with all network ports. Means I mean that, for example, this router. So this router can communicate with these ports only, these ports, because they are connected. But it cannot communicate with these all ports. Why? Because obviously they are indirectly connected, but the problem is that these networks are not available in its routing table. Only these connected networks are available. So obviously, if the networks are not available in routing table, then it cannot communicate. So first we should complete the routing table. How? By applying some static routing or by applying some automatic technology like protocols. So how? Let me show you. But before that, let me show you the one thing that if I write here looping 1.1.1. So look at the result. Yes, it can ping its own port. It can ping this port which is connected to it directly. But if we write here do ping 7.1.1.2, yes, it will ping its own port. But it can also ping this port as well. This. Sorry. Here I have done mistake. You know what? Here I have done mistake. Here I have gave same IP in the same network. So it's not possible. So I should make it correct. So 7.1.1.2. So it should be that one. How? Let me do it correct. Let me correct it first. 7.1.1.1. So I should come to this one and I should write here interface Ethernet one by one, make it down for communication now, and write here IP address 7.1.1.1 to 5.0.0 and write here no shutdown. And now as you can see here that this is 7.1.1, and if you see here it is 7.1.1.2. It's now okay. Let's now ping it again. Do ping. Yes, it can ping its own port, but it can ping its connected port as well, like this is connected. So it can ping it like you can see here. So, but if I want to ping another port in all over the network, which have different networks, so it is like internet topology, because internet means network which is consisted of different network. So yes, it is a full network which is consisted of different networks. So it is also internet topology as well. So if I want to ping from these ports to this all ports, so it will not ping. Why? Because they are indirectly connected, and it's these networks are not available in router one routing table. So that's why. So we should try to complete the routing table first. So how to do it? Let's try it now. Why you use GNS3 more than Packettracer? So the answer is that it depends on the projects, on the labs, which projects you want to configure, which projects you want to complete. So it depends on the network simulation software. Like GNS3 is best for practicing on the routing labs, and Packettracer is best for performing the switching labs. So that's why it depends. So now let's continue. So now look at this. It will not ping. How? Let me tell you practically. If I want to ping this port 6.1.1.2, so it will not ping. As you can see, it cannot ping because it's the sixth network is not available in its routing table. As you can check here in routing table, let me show you. Success rate is 0%. Why? Because if you check the routing table, then sixth network is not available. That's why this network is not available. That's why it cannot work. So how to compute the routing tables? Because in each router there is only two routes available, not all routes. So we should compute a routing table. Then they will be able. These seven different companies routers will be able to communicate in the different networks. So how many networks we have? One, two, three, four, five, six, seven. We use seven networks, and in each router routing table there are two networks. Means five network missing. So we should bring the five networks in each router so the routes should be seven complete routes. Then it can ping with each other, communicate with each other. So how we can do it by static routing manually by like a network administrator manually decide which is best path. But if we do not select static routing, then we have the option of protocols, which means there would be metric means there's some criteria for selecting best path automatically. Like in RIP, there would be like a hop count. In SPF there would be like cost, so it depends. So I think we should run here routing information protocol, which is the routing protocol, IGP interior gateway protocol. So how routing information protocol, and in routing information protocol you don't choose the best path. You know who choose the best path? This protocol choose the best path, which is known as routing information protocol. Why this protocol? How it select the best path automatically by metric. So what is the metric? Metric mean the criteria for choosing a best path in protocol. So metric in this protocol is known as hop count. What does hop count mean? Hop count means that router counts. It means, for example, this router want to communicate with this router. Okay. So, for example, there are if this want to send message to this one. So if it want to send the message, so there are two ways. One is to go through this way, and second is to go through this way. There are two paths. But the thing is, in routing information protocol, it will be automatically decided that on which path the data will travel from this router to this router, for example. So in RIP, this would be like this. Metric mean hop count. So hop count mean router count. So how many routers are there in this path? One, two, three, four. And how many routers are in this path? One. So it means hop count is less on this path. So on which path the routers would be less, router strength would be less. So RIP will select that as a best path. So this will be best path, and the packets will travel on this path, not on this path on which hop count or router are more than on this path. So that's why. So this is known as metric hop count. All about this, and now let me go to some style, and let's start configuring the routing information protocol. How to configure? Let me tell you configuration here. I should write router, and there are two versions, but I will use version one. So in version one you should write like router routing information protocol, and then you should write here network, and you should write the connected networks which are connected. One network, and another one is which network? Seven network. So same is situation for other routers to configure routing information protocol. On this router, on this company, the commands of routing information protocol would be like router rip, and the connected networks are 1 and 2. So you should write 1, and another one would be 2. Okay. On company C, how to configure routing information protocol. So you should write like router rip, and you should like the connected networks, write the connected networks 2 and 3. So 2 and 3. Okay. If we come to company D, how to configure routing information protocol on company D. So right here router rip, and write the connected networks 3 and 4. So 3 and 4, okay. And if you configure routing information protocol in company E, so how? Write these commands in company E. First write router rip, and then write the connected networks which are 4 and 5. So this is 4 and this is 5 one. And if you configure rip on company F, so how? Write here the connected networks 5 and 6. So 5 is already written, and write 6 one. And if you want to configure routing information protocol on company G, so how? Write here router rip connected network 6 and 7. So 6 and 7. So the rip would be configured. And after this, the routing table will be completed, and all 7 networks will be available in each router, and they can communicate in the different networks. So our big project will be completed. So how to do this? Let me tell you. Simply apply these commands in each router, nothing else. How? Write here these commands, nothing else. Nothing difficult in this to configure routing information protocol. Write the same commands I've written here, okay? Nothing else. And it is configured on router 1. Same for this router. Same for these routers as well. You can also give the IP address in place of network as well, like I'm giving now. It's not compulsory to give just network ID. You can also give the IP address as well. Okay. So finally, the IP is going to be configured on all companies' routers. So if you check the routing table, then all routing table will be completed now. Look at these. 4 networks were missing, and now these are available. 1, 2, 3, 4, and 2 are connected already. So 1, 2, 3, 4, 5, 6, 7. So 7. Let me write here do show IP route. So yes, 1, 2, 3, 4, 5, 6, 7. 7 networks are available. If you check here, 1, 2, 3, 4, 5, 6, 7. 7 networks are available. Means routing tables are completed through RIP protocol. So let me count it here. 1, 2, 3, 4, 5, 6, 7. 7 networks are available. And obviously these are 7 networks. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Yeah. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Yes. And finally this one. 1, 2, 3, 4, 5, 6, 7. All the completed. All routing tables are completed. Means they can ping with each other. They can communicate with each other. So our topology is completed successfully. And we will check result as well. And another thing is that we should understand this routing table as well. Now look at this. Two network is available. 8 is the setter, means the first 8 bits in this IP4 address represents the network bits, and 120 is the administrative distance and yesterday if you watched my session, then the 110 was the AD value of OSPF. So which AD value is less, so that is preferred. So OSPF is preferred over the routing information protocol because that AD value is 110 less than this one. And one is the hop count. Hop count means what? You know, again, I am repeating hop count mean router counts. Like let me tell you now. Look at this. This is router 1 routing table. Two network is where? There. This is two network. Okay. If two network, this one wants to come here. So how? It will come via this one. Via this port. One dot two, and it will come to this port. Ethernet 1 by 0. This one. And another thing is that how many routers are between two network and this router. So only one router. If you check this one, the 3 one, so here is the load balancing concept. How? Look at this. Four networks. So let me tell you the four network scenario. This is the four network, okay? This is the 120 AD value obviously, and 3 means via 7.1.1.2. So 3. So here is that 7.1.1.2. Yes, here means this network will come to this router on this way, like this, and on this 7.1.1.2, which is in front of this router. Like in this case, the two network was coming to this IP because it was in front of this port. In front of this port, this is 7.1.2, so it will come like this. And another thing is that how many routers come between four network and this router. So obviously one, two, three. So three routers. But look at this, three routers, three hop count via 7.1.1.2. But in load balancing, you can check on the other way. Also three routers through 1.1.1.2. This one which is in front of this port, and three routers. How? Between four network and this router. One, two, three. So on the both paths, as you can check here, the hop count is same, the router counts are same, and I told you when the metric is the hop count is less, that will be selected as the best path. But here the scene is that both routers strength are same on the both way. So if the strength is same, then what? Then which is best path? You know, there is the concept of load balancing. Mean the load will be shared in a balance, like the one packet will go on this way, one will go on this way, one will go on this way, one will go on this way. So the load would be balanced on the each path. Both would be selected as the best path. So this is the load balancing concept in routing information protocol. So same scenario for all routing tables. If you understand this, so all will be easy for you. And what does two mean? Two mean like three networks. So three network is this one, so means two routers. So yes, two routers, and via would be in front of this one, 1.1.1.2 as you can see, and it would be received on Ethernet 1 by 0 port. Okay. So that was it. Now let's start pinging. Okay. But before that, let me write here the networks in this topology, the Great Lake. So how many networks? 7 networks. Which one? This one first, then this one, then this network. Network ID means they represent the network, like the network bit will be on, like the first network in class A is 3, the first one, so it is 1, 2, 3, it would be on, and the last 3 are represent the host, so that would be 0, because we represent the network, so the host would be 0. The last 3 output represent the host, and the class A. So that's why it would be 0. So there would be a network ID represent a full network. So it would be like 4.0.0. It would be like 5.0.0, 6.0.0, and the last network is 7.0 because these are 7 networks. Okay. So now let's start pinging the 7 networks. So how? As you know that it is like in one network we have IP addresses. You know, in each network we have two IP addresses. Let me tell you how. In one network we have how many IP addresses? Two. In each network we have two IP addresses. In this project we have taken like a one. Let me correct it first. Now it's okay. Okay. One that why it's not working. Now look at this one. That one. That one. That one. Another one is one. That one. That one. That two. In this network, two. That one. That one. That one. We selected as the IP address. Another is two. Same here. So these were the IP addresses, two IP addresses in each network as I shown you. Like in one network there is 1.1, 1.2. Here 2.1, 2.2, 3.1, 3.2, 4.1, 4.2, 5.1, 5.2, 6.1, 6.2, 7.1, 7.2. So these are two IP in each network. So now let's do one thing. Now I will ping from each router these all IP addresses and you will see the result. If one exclamation mark at least will come, so it means that the communication is successful with that port. If even one exclamation mark will come, that will represent a successful communication. So let's start now. The pinging report results starts now. So watch the reports. On each router I will show you reports. Okay, pinging reports means communication reports. Communication is successful or not with all companies different networks ports. So it would be like 4. And you know all exclamation marks are coming in reply means with 5 packets sent 5 receive 100% successful communication success rate. And now ping 5 network IPs. So this router can communicate with all 7 companies different networks. So same situation for all routers as I can check here. This is very successful. So if you have any question, you can ask here. Is this start apology? No, 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 no. In start apology, we don't use router. We use switch or hub. Is it possible to send broadcast to all hosts with one command like ping 255.0.0 to check every host is communicating? So let me check here and give you answer practically. Okay. So yes, this router can also communicate with all companies routers. So this communication, as you can see, is successful. Okay. And let me give you answer practically. Okay. Ping and hope you will get your answer. That it's not possible. What you said. Is it possible? So no, it's not possible to send broadcast to all hosts with one command like ping. And you know what is this? This is not broadcast address. This is the 7 Moscow class A. You know what is broadcast address? This one. This is broadcast address. If you want to check here, let me check here. So yes, it's possible to send broadcast and this reply is coming. But the main yes, reply is coming. Reply to request. So it's coming. But the main concern is that your broadcast address was actually wrong. This is subnet mask, not broadcast. This is, and I've checked and practically I've gave you answer that the reply is coming and it can give you reply like again I'm pinging here on another router. Yes, reply is coming. From which IP address is 1.1 and 2.1.1.2 means 1.1 and 2.1.1.2 this one. Look at this. I've checked on router 2. So the broadcast reply is coming from 2.1.1.2 and 1.1 means on this router broadcast reply is coming from this IP and from this IP. Means like a broadcast is coming on this port to this router and on this port to this router. Means from all devices the broadcast is working. So it means yes it is possible. But actually your broadcast address was wrong. So that's why. SSI use class A. Which is 255.0.0.0 was. Sir, IP addressing scheme, do you recommend IP4 or IP6? What what are you asking about? I'm not like the man who decides that which will work in all over the world. Obviously, it depends on the whole company like of a people who they will decide that which is best or not. If I will decide, that is not in my authority, etc. I'm just your instructor. And if you ask like that, then you know IPv6 is more better than IPv4. Why? Because the people estimates, the expert in the networking estimates that IPv6 will never finish due to its total strength. But IP4 is limited, so that's why the subnetting concept came to save the IP4 addresses from its wastages. And there's another question from is host and node same? No, node mean device. Device can be any device, intermediate device, end device, standalone device, whatever. But host mean device to which we can assign IP address. It means host. Like in virtualization, we use concept ESXi host. So what does it mean? It means that ESXi is hypervisor, but on which hardware it is installed. If we can give IP configuration to the device, which means there is ESXi host. So host always means that device to which we can assign what logical address, IP address. So this is host. If I give you an example, TV. I mean simple TV. Nowadays the LEDs or some TVs came which to which we can assign IP. I mean that uh, they can have the facility of internet. Like we can run the internet on those TVs. But if you look at the old TVs, then that was not host because we cannot assign IP. Mean we cannot run the internet on those devices. So host mean what is the problem here? So yes, internet's not working basically. So that's why I'm going to end the session. And I will also give the surprise answer. So you should wait 48 hours in place of 24 hours of waiting the answer of the question which I raised in the previous session that those were 8 physical loaders, but how they can be 45. So I will give you answer in the second last session of this networking bootcamp. So wait for it. I cannot give because the live numbers are not available now due to the network issue. So that's why I am disconnected from them. So I cannot answer now. I will answer after 24 hours. So there is now 48 hours suspense to give the answer of the switches. In previous session, I have told you that how the 8 switches can be converted to, or how they are 45 switches, not 8 in reality, but they are physically 8. So I will give answer in the second last session. This was the third. This was the third last session of this bootcamp, and let me show you this. Basically, I have shown you the results and the same result for all routers, like it can ping all ports. So it means that our lab is completed successfully, in which all company routers can communicate with each other in different networks. So all 7 companies can communicate with each other in different networks. So it is completed successfully. And we, if we check here the broadcast where it is here. So how it will how it will be like. So now as you can see, it should come from 4.1.1 and 5.1.1.2. Look at this 5.1.1.2, 4.1.1. Why? Because some will come on this, some will come on this way. So that's why. Look at this 5.1.1.2 and 4.1.1.1. The play is coming. Okay. So our lab is completed successfully. In this session, we have completed one lab, one big project. So that was a too much large project for all of you. And thank you so much with us. We will share this content with you as well. Now let's save the configuration. WR command, which means write the configuration from RAM to NVRAM and save it on permanent basis. So let's save this configuration and then close this session. Okay. You can also view this command, which means that copy configuration from running dash config to startup dash config means running dash config that RAM and startup dash config means NVRAM. So it means that copy the configuration from temporary memory to RAM to NVRAM permanent data memory. So these all are saved. So this was our third last session of this bootcamp. See you in the second last session of this bootcamp. Allah Hafiz. Goodbye.